Welcome to this video lecture on scientific research in information systems. This video lecture is part of a course usually held at the University of Hamburg, and it is based on the book with the same name, Scientific Research in Information Systems, published in its second edition by Springer in 2021. In this set of video lectures, we will discuss computational methods, which is one of the chapters in that book. And in particular, in this video lecture specifically, we will talk about the role of digital trace data. For orientation, with computational methods to research, we mean research processes such as data generation, discovery, data processing or cleansing, and data analysis or data interpretation that are being supported through algorithmic software tools that provide computational capabilities. Meaning that with computational research, we mean research that is carrying out with the help of or through algorithmic software that take over or support part of typical research process, such as the ones mentioned here. If you want to use an analogy to contrast computational methods with other types of research methods, such as quantitative and qualitative methods, where quantitative methods have a focus on numbers, qualitative methods have a focus on words, and design methods have a focus on artifacts, you can think of computational methods as having a focus on digital trace data. And in this lecture, I want to explain more about what we mean with digital trace data. Digital trace data are evidence of activities and events that are logged and stored digitally. So this broad definition encompasses everything that we leave a trace of on digital platforms in the online world. Activities could be things that I click, activities that I make, decisions that I do, anything online, and events are, of course, anything that occurs online, like a notification, an email that comes in, a push notification that I receive on my phone. Anything that is occurring as being logged and stored digitally is a digital trace, and the set of digital traces is digital trace data. Now, these are not new types of data, right? So ever since the invention and diffusion of computers into the workplace, we've had traces such as emails or transaction data, process data from enterprise systems and other types of organizational systems, technological systems that organizations use. In the age of social media, we have things like Twitter posts, or other types of comments on any of these social media networking platforms. Yeah, TikTok, Facebook, Instagram, anything. A like, a tweet, or a hashtag, a repost, a retweet, anything like this. All of these are forms of digital trace data. So this is not necessarily a new phenomenon. What is different is that these digital technologies have permeated basically every aspect of organizational work life. So in a way, work is unthinkable without computers and digital technologies, but also our personal life, right? How we work, but also how we play, sports, sleep, social activities, personal activities, health, shopping, exercise, anything of this usually is now at least involving, if not enabled or mediated or fully embodied through digital technologies, right? Meaning that we now have a lot more digital trace data about a lot more activities, both within and across work settings and also personal life settings, right? So think about if you have a smart toothbrush that records biohealth data by wearables, right? Whether it's your toothbrush, whether it's be your Fitbit, anything like this. Your home may have energy meters. You might have digital television by now. And of course, you might have an electric vehicle, a scooter, an e-bike, anything like this. All of these generate traces about lots of activities and events in your personal life. And of course, if you think about my work, most of that, or virtually all of that, is in front of a computer where we have digital traces of everything I do at work, such as recording this lecture at the moment. All right, so digital trace data are not necessarily new, but the sheer volume and diffusion of volume digital traces is quite different today. Now, I wanted to give you an example of how this has changed over a very short period of time, namely from, let's say, the 2000s when I was a student, where we had very limited digital traces about part of activities. Back then in the 2000s, we did have already organizations communicating at least partially via email, but certainly not completely via email. So we had part of organizational communication occurring through email. Or let's say as a student, part of the communication between the university and me was via email, certainly not all of that. We had some systems, think of Open OLAT or Stine here in Hamburg. Back then, these systems didn't yet exist. So some of that curriculum and, your program management of your undergrad or your postgraduate study program wasn't actually through digital system, meaning we didn't have any digital trace data about, let's say, your study progresses at that point. And of course, all of that changed over the last 10, 20 years with some of the proliferation of digital technologies that we see through in the permeation through every aspect of our life. And here's a very early example of that. About something that happened in the 2000s, I think it was around 2005, if I remember correctly, 2006, 7, 8, an oil spill by a platform by BP, I believe, British Petroleum in the Gulf of Mexico. There's actually also a movie about this with Mark Wahlberg in it. But it's a real event that happened, and it was also the time where we had sort of the beginning of the social media, a boom that we've seen and that we have now, right? So the time where hundreds of millions of people for the first time ever got connected to digital technologies. And in this period, one of the first pieces of research information system that actually used digital traces was a study by Emma Vast, Hani Zafadi, and others that looked at how people use social media to organize what's called connective or collective action, how they organized and communicated about that oil spill and some of its consequences through a platform such as Twitter. Yeah. So at that time, or again, around 2005, there were around 23,000 tweets with a hashtag oil spill or BP oil spill, right? So something that was connected to this event via this hashtag, 23,000. Now, that may not sound like much if you think about that. I think Cristiano Ronaldo has about 600 million followers on Instagram. So there's a lot more activities and events and sort of traces there. But at that time, that was quite a lot. Moreover, 23,000 tweets is a lot of traces to be analyzing the classical research sense manually. Yeah. So what this study actually did, it looked like how individuals, everyday people, engaged in collective action, organized themselves as a collective to form a movement, yeah, sort of a political movement that was about, save the pelicans, how bad is BP, whatever, save the environment, all these sorts of collective action initiatives through social media by co-producing and circulating content with individual, tweets, basically. And so some of the things they did is, for example, they looked at certain types of topics that were being discussed in these 23,000 tweets. So one of them was stop the drilling, boycott BP, and hair and fur. Now, I mentioned hair and fur here because you may not remember this or you may not even know this. At some stage, when it was clear that the oil spill sort of left basically a lake of oil on top of the Gulf of Mexico in the ocean, and it sort of impacted a lot of marine life, like the pelicans, etc. One of the ways you could actually help these animals in the sea life was to donate hair and fur, because that would absorb some of that oil from the water surface, right? So literally, this was a collective action trying to get people to donate hair and fur, right, towards the end. In the beginning was stop the drilling, boycott BP, which are kind of different collective action, where the action is to penalize or sort of have some sort of movement against BP, who was held responsible at that time. And you can see on the right-hand side that these collective actions had different time periods, sort of different periods of intensity, and that's what they looked at for a while, keeping in mind 23,000 tweets, and they basically did empirical research on this, meaning they coded and categorized and analyzed them fairly manually. And you can think about how much work that actually is. Here's the second example of digital trace data. This is a study that I was involved in that looks at how we can use digital traces to understand better what goes on in a hospital. So what you see here is the room layout of the University of Rochester Dermatology Day Clinic. A dermatology clinic is where you go to have your skin checked, right? So maybe you go for skin cancer, like a mole scan. Maybe you go to get a blemish removed. Maybe you have some award, anything that has to do with the skin, basically. And a day clinic is somewhere where you go in, but you also leave. You don't stay overnight. It's not a hospital, so to speak. It's a classical day clinic, meaning that you come in and the first thing you always do is go to the reception, right? And say, hi, my name is Jan. I have an appointment. And they say, thank you very much. Please go to the waiting room, which you see at the top. You have a medical doctor's office on the top left. You have certain storage rooms, sold and clean, where they keep papers and towels and stuff like this. You have examination rooms and procedure rooms, right? Examination rooms could be something where you have, let's say, an X-ray scanner. A procedure room is something where, maybe, for example, you take a sample or you cut out a ward or anything like that, right? And in the middle, you have a nursing station, NS, where a licensed practitioner would sit. So this is what a clinic looks like, and it's fairly standard. You would see this at any doctor's clinic. And of course, you have people working there, right? You have a physician, you have a receptionist, an admin staff. You may have a resident, some doctor that is working here for a while, maybe a specialist. You have a clinician tech, usually someone that can handle an X-ray scanner, or other types of medical technology. And of course, you have a licensed practitioner. So these are typically people that work in such a clinic. And of course, all of these now also have an information systems, right? They all have workstation with computers, which are here highlighted green, in all the rooms, right? Where they have some of their patient information systems, maybe the operating system for technology that they have, a receptionist, like a scheduling system for the admin stuff, and so forth. Somewhere where they can procure new material and do replenishment and all these sorts of things. What that means is that these systems now generate digital traces, everything that people log in these systems as they go through their day-to-day work, where patients come in, go to the waiting room, go to see the doctor sends them for an examination, the person sees this, the nurse takes a blood sample, things like this. In the end, you end up with the receptionist again. Yeah. So what you can do here, if you grab all these traces from the digital, from all these technologies, from these systems that the people are using, you can try to reconstruct for how these processes of visiting the dermatology clinic looks like. And this is a way to look at this, right? What you see here on the top, where we say clock time, is 25 patients coming into the clinic at one day. Yeah, on a Monday morning, 9 a.m., the clinic opens, people come in. What you see over time is that, of course, people don't come in, there's not 25 people at once. They come on throughout the day. Yeah. And some of them stay longer, some of them not. And, towards the end, of course, there's no new patient coming in because the clinic closes. That's clock time. Now, the bottom chart shows the same activities in event time. So basically normalizing every patient visit by the time they arrive. Yeah. And what you see here in both of these charts are different color-coded dots. These are different type of activities. An activity could be registering with the admin office, seeing the nurse, seeing the doctor, doing an examination, and so forth. What you see at the bottom for these 25 patients is they all start with a blue dot, which is, as you may imagine, registering with the admin office at the reception. When you go into a clinic, you don't go straight to the doctor. You always see the receptionist first, right? And after this, it depends, right? You see that many, but not all of these different patients, these rows, have this light gray, pinkish activity that is sometimes short, sometimes long. That's a patient sitting in the waiting room. Sometimes you wait not at all. Sometimes you wait a little bit. Few of those, the ones in the middle, apparently, wait a lot until they see a doctor. What you also see is that not two visits are equal. They're all different. Some of them are longer, some of them are shorter. They all have different activities, which you can see here through the color coding. So what looks like a simple process, see the receptionist, wait in the waiting room, see the doctor, have your procedure done, go home. In reality, every patient visit is very different. Yeah. So that's something you can see, and which is very common for typical processes at work everywhere. So we can try to figure out what's going on here, right, with this digital trace data. One way to look at this is what's called the social network. We can look at, well, in all of these processes, who's working with whom? Who are the actors involved? Remember, there's a nurse, there's a receptionist, there's a doctor, there's a specialist, there's a technician. If you look at the relationship in carrying out the work and seeing all the patients, you get a diagram, a network graph like the one on the left hand here. Yeah, these are the relationships between the involved actors. What you can see here is the most important person in the clinic is the blue dot, right? The blue dot that is right in the middle. The blue dot is not the doctor. The blue dot is the receptionist. Yeah, the receptionist is basically the key figure that orchestrates everything that's going on. Yeah, so that's one thing you could figure out by looking at the digital trace data. Of course, what you could also see, what is something that you saw in this event time graph, is you cannot look at the actors, like who talks to whom, who hands over work to whom, but what are the actions? That is what we call a process model, or in this case, a process network. So what are the relationship between the involved actions? And you see here that it looks like something that we call a spaghetti graph. It's like an unholy mess of activity going on. It's very difficult to see any pattern. Everything is connected to everything, except for a few activities at the top that seem to be the endpoints of something. And you see that little, purple one in the middle, that where everything goes to and from. That's very likely, I would have to look that up. That's likely an activity that involves the receptionist, like scheduling an appointment, registering when you come in, stuff like this. This is really a central activity. Now, with these traces, you can, of course, dig a little bit deeper. So for what you see here is you can have a look at, well, what sort of systems is using which person to do which task in what sequence? And what you see here is something that we call disentangling the spaghetti graph. We see more structure emerging here, right? You see something that looks like clusters of activities. Do we have some sort of central activity in the middle where a lot of things that connect a lot of different activity clusters around them? So the one way to think about it is that there are a series of steps that are, in this overall process. There's actually a series of smaller steps that are being done. Like when you go see the receptionist, see it in the waiting room, do a few things there. Maybe you call again and see when you can see the doctor, etc. That's one cluster of activity. And then you go and see the doctor, and the doctor does a diagnosis and checks your medical records and all these sorts of things with their patient information system. That could be, say, the cluster of red activities you see at the top. Then you go back to the receptionist, wait a little bit longer, and then you go into an examination room. So you see that unholy mess actually has more latent structure underneath this, that it becomes a little bit more apparent. Yeah, so this is something you can uncover with digital traces because you have these granular, minute, detailed logs of these activities, of everything that's going on, everything that's logged digitally. Now, I wanted to show you this graph as well, because here we added one more detail to this analysis. All these activities also not only happen, with a person doing something, registering it in a digital system about some action that they get just carried out, right? So the doctor typing in the diagnosis into the patient information system, but they're also in a particular location, right? So what you don't know, what I haven't told you yet, is that the University of Rochester Dermatology Clinic actually has 3 buildings. Yeah, so literally like left wing, right wing, and the central wing. And one of the things you see here, if you look at where are these locations happening, you see that most activities are in one location. Yeah, you're either in the yellow and the blue, or in the light blue rooms. That makes a lot of sense if you think about it, right? So it's very unlikely that if you go to the left wing day clinic and you go and see the doctor, it's very unlikely that you register there and then go to a different building. So in fact, that only happened once, as you can see here, right? You can see that there's one trace, there's one connection between things that were in the location on the bottom left, and where for some reason the patient for that case went to see a doctor or a specialist or someone else somewhere else. And you can now and figure out and say, like, okay, what happened? What's with this patient? Did he have to see a specialist somewhere else? So you see here with digital traces, what it allows us to is to go to pretty minute detail, trying to analyze what is the context of activity, what is really going on at a much more granular level that would have been feasible, let's say, manually. Because what we've done here, keeping in mind, this is just one day, just 25 patient visits. This already has about, if I can remember correctly, 65,000 traces. So think of an Excel table with 65,000 entries, rows in it. That's the data that we use here. And of course, we didn't do this manually. We used an algorithm that created these different graphs, these network graphs, right? And that is something that makes this research computational in nature. So this is something you can do, right? So it gives you quite enormous volume and sometimes very rich, very minute, very granular detail about what's going on. That makes it very interesting types of research, right? So if you think about the BP oil spill example, it would have been next to impossible to figure out how people across the planet would organize themselves to launch certain actions like boycotting BP or collecting hair and fur to save the environment, and without these digital traces, right? It's next to impossible to figure out what's going on for activities at such a scale. In that process example that I've shown you, it's next to impossible to do any of this manually, right? If you were to do this manually, maybe you would have to sit in the day clinic and observe and take notes of everyone that comes in and every activity that's going on. Now, you can do this, of course, for a patient visiting a doctor in a clinic. But as I said, this Rochester is a big clinic, has 3 buildings. It has multiple patients, multiple doctors, multiple specialists in every of these clinics. How the hell are you going to follow all of them all the time? Yeah, you would have to shadow every single person, meaning that you know, for 25 patient visits, you need 25 researchers, right? So some of that stuff is basically next to impossible or very infeasible to actually study manually. But of course, with digital traces, we basically get an Excel spreadsheet. But let's have a look at what is different about digital trace data. One key difference in digital trace data to other types of research data, such as the one we could have generated manually through empirical, quantitative, or qualitative research, is digital trace data is not designed, it's organic, which means that this naturally happens as a byproduct of activities that are carried out online or in the digital system. It is not data generated for the purpose of research. So when I run a survey, I design the instrument and thereby I design the data that I'll collect. If I do a qualitative study and I go with an interview protocol and maybe a logbook where I try to write down my observations of people, I am designing, I'm constructing this research for the data for the purpose of research. This is not the case with digital trace data. Digital trace data just occurs as a byproduct of people doing things through digital technologies, online, you know, in a system, whatever else. Yeah. So digital traces appear organically. We find and collect and then harvest and analyze them. What that means is that we have very little control over this data to begin with. The data generation process can be opaque, can be unknown. We may not know where this data is coming from, in what context it was generated. A good example of that would be the BP oil spill, where lots and lots of thousands of people used Twitter to tweet their opinions and, you know, whatever they were doing about these collective action movements. We know next to nothing about these people. We don't know who they are. We may see their Twitter profile if we, you know, care to check on these profiles, but you know, they could be anonymous, they could be whatever. We don't know in what context and what situations these tweets were retweeted, liked, you know, maybe it was meant to be sarcastic or ironic. We don't know, right? So the data generation is unknown or at least very opaque to us. We have very little control over that. In normal research, we are controlling the data and we know very much about how that data is generated, where it's coming from, right? So this is a hugely different process because we don't know whether we can trust this data. We don't even know whether a bot created this or a human being, right? A second challenge in digital traces is that digital traces can be unstructured and heterogeneous. I've shown you simple example of tweets. But tweets are not that simple to begin with, right? It could be text, could be images, there's hashtags, could be numbers. The traces from the day clinic are actually more difficult than made out to be. These are, you know, different systems and different data formats creating activities. But, you know, if you think about social media, it could be anything. It could be likes, could be tweets, could be filters, could be videos, could be sounds, could be all sorts of things. That is, of course, a great strength because it can be very rich data, right? Richer than, let's say, the numbers we generate through a survey where we get a bunch of numbers from 1 to 7. But of course, unstructured heterogeneous data is very difficult to analyze. You can't just straightforward put that into a statistics tool, for example, right? How do you analyze a bunch of TikTok videos, for example? Yeah, just to give you one example to clarify this is from a study done at the University of Hamburg. And the study looks at sort of social media, political communication, and how, you know, our consumption of political news through social media, how that occurs, right? So And that is very complicated because it goes through multiple layers. So it's a multi-step media journey, right? So politicians, they may want to, let's say, promote a new, like save the ocean plastic strategy. We can hear about it maybe from politicians we follow. We can from news reporting, political communication, such as the European Commission, having web pages or maybe tweets or LinkedIn posts or whatever. Of course, we have regular media talking about these things, like the New York Times. But we also have something like social media influencers, for example. Yeah, people that have lots of followers on Instagram and TikToks, and they also talk about political news, right? And now trying to analyze which of these types of communication strategies through which medium is effective or is infecting people in what particular way is now very, very difficult. On the one hand, you have press release statements that could be text. Then you have media, New York Times, like newspaper articles or Tagesschau news reporting, these sorts of things. And then you have whatever people do on social media in whatever format, in whatever way. And of course, they all talk about the same subject matter, let's say the plastic strategy, very differently. For example, the commission could be a political, approved sort of press release, maybe factual. New York Times could be a commentary, could be a column, could be an opinion piece. And social media, like we have very little control about what they say or how they feel about it, what they say. Maybe they like it, maybe they don't, God knows what else. And of course, they all use very different types of data formats. So you see, it gets very, very, very tricky, heterogeneous, and unstructured if you were to analyze something like which of these different communication strategies is actually most effective in influencing people to, let's say, like or dislike this particular political strategy. A third challenge in digital traces is just the sheer volume of it. Yeah, typically when we deal with digital traces, we deal with millions or thousands, hundreds of thousands, or even millions of traces. Part of the reason is that it's usually very fine-grained events activities. So you can think of it, we could technically log every keystroke, every mouse movement, and some people research that. But even if you just look at sort of tweets, back in the BP oil spill, this was on the very early days of Twitter, where 23,000 isn't a great deal of Twitter comments these days. But of course, it was huge and is already too much to act. Well, it was just about enough to do manually. They still analyze this data manually. But if you think about, if you look at Cristiano Ronaldo, who I looked up, has 660 million followers at the moment on Instagram. If you want to see what all of them do in response to just one post, that's basically impossible to do manually, right? So it's just the volume, the normative, the volume presents a challenge to most typical research process that we have. And the fourth challenge is that digital traces are event-based, meaning that all these logged activities, behaviors, and events all happen in a particular point in time that is also logged, right? So there's basically a timestamp on every trace. This is great because it allows you to study how things unfold over time, how processes change over time, how people do things over time, right? You can see which of these activities occur earlier or later, how much time passed in between. All you can do because you have these timestamps. But temporal data, timestamp data is very difficult to analyze because most of our typical statistical analysis tools don't actually look at that. If you think of a classical survey, the timestamps don't appear in there, right? So it's great and challenging at the same time. So this brings me to the end of this video lecture. You can see that digital trace data, at the one hand, opens up a new realm of possibilities of studying things that could have not be studied otherwise, or studying things at a scale that wouldn't have been possible otherwise. So this is great, but it comes with its own challenges of volume, event-based, heterogeneity, and organic nature, which make it difficult, right? So it's both great and challenging at the same time. This is the end of this video lecture. Thanks for watching, and thanks for listening.